All right, let's look at section 9.7, exponential equations. If we have an exponential equation and we can write it in the form b to the u equals b to the v, then we can solve the equation u equal v. If the equation cannot easily be written in the form b to the u equal b to the v, we're going to use the logarithm property of equality to take the log of both sides. Typically, we're going to use a base 10 or base e log because those are the logs that are going to be available on the calculators you can use on your exams. We're going to use the power rule of logarithms to bring down any exponents, and then we'll be able to solve for the given variable. Let's take a look at solving 4 to the x squared minus 2x equals 64 by writing 64 as 4 cubed. Now we have exponentials on both sides that have the same base, so we simply set the exponents equal to each other. And we obtain x squared minus 2x minus 3 equals 0 as our standard quadratic equation. We factor it and we use the zero product property to solve and find that x is either 3 or negative 1. And I can check this. The check is not going to be required unless you're asked to show it. And I'm going to just show you the check on this one. I'm going to replace all x's with 3 to get 4 to the third equals 64. And we know that's true. When you square 3, you get 9 minus 2 times 3 is 6. When I let x equal negative 1, when I square negative 1, I get 1. Negative 2 times negative 1 is plus 2. Again, I get 4 cubed equals 64, which we know is true. All right, so let's look at a more complicated problem, which we find with number 2. 3 times 9 to the x minus 1 power equals 81 to the 2x plus 1 power. So we're going to write both sides of the equation as 3 to some power. We're going to start by writing 9 as 3 squared, recopying everything else, and 81 is 3 to the 4th, recopying everything else. All right, so we need the power to power rule for exponents, which says a to the m to the nth is a to the m times n. So on the left, 3 in the parenthesis is going to be raised to the 2 times x minus 1 power. On the right, 3 is being raised to the 4 times 2x plus 1 power. And we're going to distribute. So on the left, inside the parenthesis, 3 is to the 2x minus 2 power. On the right, 3 is to the 8x plus 4 power. Now we need the fact that a to the m times a to the n is a to the m plus n. And we're going to think of this 3 on the outside of the parenthesis on the left as 3 to the minus 1, because there's an unwritten power of 1 there. So we add 1 to 2x minus 2. And that gives us 3 to the 2x minus 1 on the left, and that equals 3 to the 8x plus 4 on the right. So we have a single exponential whose base is 3 on both sides of the equation. Now we simply set the exponents equal to each other. And this is going to allow us to solve our equation. We're going to add 1 to both sides and subtract 8x from both sides. So we wind up with negative 6x equals 5. We divide both sides by negative 6, and we get x equal to negative 5 over 6. So that's my solution. All right, now we are going to look at how do we solve these equations when we can't write them both as exponentials to the same base. We're going to use logarithms. We're going to apply the log, either natural or base 10, to both sides of the equation. So we're using the logarithm property of equality, and then we're going to use the power rule for logarithms. Here's an example. So we have 7 to the x plus 3 power equals 4 to the 2 minus x power. We cannot easily write 7 and 4 as exponentials to the same base. So we apply the natural log to both sides of the equation. Then we apply the power rule for logarithms, and we get the first step that you see written in the solution here. And notice, because the exponents have more than one term, we have to parenthesize when we use this power rule for logarithms. Now we distribute, and we add x log 4 to both sides of the equation so that we get terms that have x in them on one side, terms that don't have x in them on the other side of the equation. And then we subtract 3 natural log 7 from both sides of the equation as well. And now we factor out x, and we're able to divide by the term that's being multiplied by x on both sides of the equation, and we're able to solve. Now, what this example does is it uses log properties so that you have a single logarithm in your numerator and a single logarithm in your denominator. It is not necessary to do that. But notice in the numerator you've used the power rule for logarithms and the quotient rule for logarithms. And in the denominator you've used the product rule for logarithms. However, you could find the answer without making this a single logarithm. We have a little error here. This should be 343, not 342. So we'll correct that. However, when we look at our first problem, we are not going to go through that process. So let's take a look. We do get an approximate answer, approximate value of x. So let's take a look at using this property on number 3. So we're going to apply the natural log to 7 to the x and the natural log to 15. Now we're going to use the power rule for logarithms. Natural log of 7 to the x is x times the natural log of 7. We're going to divide both sides by natural log of 7. This gives us x equals natural log of 15 divided by natural log of 7. And we can go directly to our calculator to get that result. But when you hit your natural log button, if it starts with a parenthesis, you will have to close that parenthesis out to get the correct answer. And we'll find that that is approximately 1.3917. The most efficient thing to do is to use your calculator and not to approximate the natural log of 15 and the natural log of 7. However, if you do feel more comfortable doing that, then you'll need to write those approximations to 6 decimal places so that in the end you can round to 4. So the natural log of 15 is approximately 2.708050. Natural log of 7 is 1.945910. When I divide those two numbers, I get approximately 1.3917, which I had known previously. I'm just showing you another way to work the problem. However, you're going to be best served if you know how to use your calculator. Let's look at number 4, which is a little more complicated. I'm going to apply the natural log to both sides of the equation. Now I'm going to use the power property for logarithms. I have to parenthesize 4x minus 7 since that has more than one term in it. And that gets multiplied by the natural log of 8. That's the power rule for logarithms. I have to parenthesize 5 plus x. That gets multiplied by the natural log of 11. That's the power property for logarithms. Now I'm distributing. Now I'm going to get everything that doesn't have an x in it on one side of the equals, everything that does on the other side of the equals. I'm going to do that by adding 7 times the natural log of 8 to both sides of the equation. And then I'm going to subtract x times the natural log of 11. Oops, and let me make a correction there. That should have been an 11, not an x. I'm going to subtract x times the natural log of 11 from both sides of the equation. So that gives me 4x times the natural log of 8 minus x times the natural log of 11 equals 5 times the natural log of 11 plus 7 times the natural log of 8. I'm going to factor out an x on the left side. X is multiplied by times 4 times the natural log of 8 minus natural log of 11. So I'm going to divide both sides of the equation by what x is being multiplied by, and that allows me to solve for x. I'm going to divide out 4 natural log 8 minus natural log 11 on the left, and I'm going to use my calculator to solve this, but I have to use parentheses as shown to do this correctly. If when you hit your natural log button on your calculator you don't get a parenthesis, then you don't need the parenthesis around the 11 and the 8. But if when you hit your natural log button you get natural log and a parenthesis, you will need those parentheses. Alright, so you have to parenthesize as shown to find that x is approximately 4.4841. And we can check this. Now, we go back to the original equation, and we're going to multiply 4.4841 times 4 and then subtract 7. And that raises 8 to the 10.9364 power. We're going to add 5 to 4.4841 to get that 11 is being raised to the 9.4841 power. And I'm going to use my calculator, and I see that both sides are approximately 7.5 billion. They're a little different because we are approximating, but they are approximately equal. So that's how I use the calculator and logarithms to find the value of x to 4 decimal places. Alright, make sure you use the parenthesis. You do not need to get a single logarithm in the numerator and a single logarithm in the denominator.